This is Mr. Baruch, and this is going to be our flipped classroom lesson on matter and parts of matter. As always, you should take notes not only on what you see on the screen, but also on what I say. Feel free to pause this video at any time. So let's begin. What exactly is matter? Well, matter can be defined as having these two properties, something that has mass and volume. Now, what does that mean? Well, mass, for lack of a better word, is the amount of stuff that's contained in it. A lot of people use the word weight instead of mass. However, weight involves gravity, and mass is irrelevant to gravity. But since we're not going to be doing experiments outside of Earth's atmosphere, you can pretend that mass and weight are the same thing. Volume is the amount of space something takes up. So, matter has to have mass and volume. Now, there are two different types of matter. We're going to break matter into two categories. They are substances and mixtures. So what exactly is a substance? We'll start with that one. A substance is something that is pure. It is only one thing. So in order to be a substance, it cannot be mixed with anything else. Whereas a mixture obviously is something that is mixed. It's more than one thing. Now, let's go on a little bit more. There are two types of substances, and they are called elements and compounds. So let me explain the difference between an element and a compound. First, let me give you some examples of elements and compounds. Okay, I have a few listed here. We have things like carbon. The symbol for carbon is C, and at room temperature it's a solid. That's a little S right there. We also have mercury. Mercury is a liquid at room temperature, and at room temperature it stays a liquid. Helium, symbol He, is a gas at room temperature. These are examples of elements. Now, what exactly is an element? We know it's a substance, but what does that mean? It is the simplest substance. It cannot be broken down any further. Now, how does this differ from a compound? Well, I have some examples of compounds here. I have NaCl, that is sodium chloride, also known as table salt, and at room temperature it's a solid. This one I'm sure you're familiar with, H2O, and that symbol there is an L, it's a liquid at room temperature. And here's carbon dioxide, containing 1 part carbon, 2 parts oxygen. It's a gas at room temperature. So how is a compound different from an element? It is two or more elements that are chemically combined. As you can see, all the elements that are here, 2, 2, 2, there's Na and Cl, H and O, C and O. These are called binary compounds. Now, why are they called binary? Binary means two different elements, and these compounds contain two different elements. I just want to list a different type. Here is C6H12O6, solid at room temperature. It's not a binary compound because it contains 3 elements. So it's simply a compound but not binary. Now, we said earlier that a substance has to be one thing and it has to be pure. So sometimes people get confused. How can NaCl be one thing when you can see 2 different elements in them? Well, the fact is, once they are chemically combined, they are fused into one new thing. And that means it does not have the same properties as the original elements. For example, if I were to show you pure sodium, sodium is a metal at room temperature. It is soft, it is shiny, and it has a very unique property that when you throw it in water, it explodes. Chlorine, on the other hand, is a green, deadly gas. It was used in World War I as mustard gas. You combine these two things together, this explosive shiny metal and this green deadly gas, and your product is no longer green, it's no longer shiny, it's no longer metallic, it's no longer a gas, it is now a white crystalline powder, which we call table salt. So as you can see, a compound, once formed, is almost like you've made a brand new element, but we don't call it an element because it contains different parts that are chemically combined. And again, we can break those up. Given enough energy, we can break sodium chloride back into sodium and chlorine, but that's a lesson for another day. Now, continuing this a little bit further, if I were to take the smallest part of any element I could, the tiniest bit of carbon or the tiniest drop of mercury, I would call that an atom. An atom is the smallest part of an element. It is the tiniest part that literally you can't break any further and still call it matter. Now, of course, today we can break atoms. We can talk about that when we do nuclear chemistry. But if you were to break an atom, it wouldn't technically be matter anymore. Likewise, the smallest part of a compound is called a molecule. It is the smallest part of that compound that still has all those properties that that compound has. Now, again, you could break that molecule into atoms, but then it wouldn't be that compound anymore. We'll talk about this a little bit further in a second, but let's go back to the mixtures for a second. So, just like substances were broken into two categories, we can break mixtures into two categories also. We're going to call them heterogeneous and homogeneous. Now, heterogeneous means an uneven mixture. It is not the same throughout. A good example would be mud, because the top layer of mud is more liquidy, the bottom layer is more solid, because the sand and the water don't mix evenly, it settles. Whereas a homogeneous mixture, or another word for homogeneous mixture is solution. Make sure you know that word, because a lot of times we use the word solution instead of homogeneous, is an even mixture. It is the same throughout. And a great example of that would be salt water. And I can write salt water as NaCl and then in parentheses AQ. AQ means aqueous, means dissolved in water. So anytime you see the letters AQ, that is a homogeneous mixture or solution. And again, I know it's a solution because if I were to take one drop of that salt water, it would be the same as any other drop of that salt water. From the first bit to the last bit, it is the same throughout. All right. Let's go back down here to atoms and molecules, and I just want to explain one last thing. If I want to make a compound, it's pretty easy. All I have to do is take some elements and combine them to make compounds. For example, I can combine carbon with oxygens, and then I can make carbon dioxide. The same is true if I want to work in small scale. Let's say I want to make a molecule. Well, again, I just have to take some atoms and combine them to make molecules. So atoms to molecules is small scale, really small scale. Elements to compounds are large scale. But other than that, it's the same process. Elements make compounds, atoms make molecules. So I could actually draw a line from here to here and from here to here. There's only one exception to this, and that is that the definition of a compound is two or more elements that are chemically combined, but they have to be different elements. That's really important. Two or more different elements. Whereas a molecule is two or more atoms that are chemically combined, but they do not need to be different. Which means I could take two of the same atom and make a molecule. Now, what exactly does that mean? What does that look like? Well, let me show you. There are these things called diatomic elements. These are two of the same elements combined. Examples: H2, which is hydrogen, N2, nitrogen, O2, oxygen, F2, fluorine, Cl2, chlorine, Br2, bromine, and I2, iodine. These are called the diatomic elements. They are two of the same atom that have been fused together, and therefore they are molecules now, right? Because they're two or more atoms. However, these are not compounds, are they? Because to be a compound, you need two or more different elements, and they're the same element. So, a molecule is two or more atoms, whether they're the same or not, but a compound has to be two or more different elements. That's the only tricky part. Eventually, you're going to need to memorize these diatomic elements. There are only 7 of them, and I have a way to memorize them. Here's how I teach my students to memorize them. I made up a nickname for them. I call them the GEN series. G-E-N. Why G-E-N? Because every element that ends in the letters gen is going to be found in nature as diatomic. For example, this is called hydrogen, this is called nitrogen, this is called oxygen. Now, you might wonder about these other four, fluorine, chlorine, bromine, and iodine. They don't end in gen. They don't, but in the periodic table of elements, they're all found in the same column. Column or group number 17, and group 17 has a name. That name is called the halogens. Therefore, I call them part of the gen series. Fluorine, chlorine, bromine, and iodine are halogens. They're gens. So, just to summarize one last time, matter is anything that has mass and volume. There are two types of matter, the pure type, which are substances, and the mixtures, which are called mixtures. If something is a substance, it's either an element or a compound. Elements are the simplest substance. They cannot be broken down. Compounds are two or more elements chemically combined. If you see letters S, L, or G after them, that means solid, liquid, or gas. Remember that compounds have to be two or more different elements that are chemically combined. They have to be different. The smallest part of any element is an atom. The smallest part of any compound is a molecule. Two or more atoms combine to make a molecule. Remember, that's not the same as a compound because you need two or more different elements to make a compound. And then finally, we have the whole mixtures. We have heterogeneous, which are uneven, and homogeneous, which are even or called solutions. And if you see the letters AQ after it, AQ means aqueous, which means dissolved in water. By definition, anything that's aqueous must be a mixture.